Hey stats class, now we're going to look at the next group of calculators, which are the 7-2 calculators. And notice there's a pretty good number of 7-2. There's 1, 2, 3, 4, 5, I believe. 1, 2, 3, 4, 5. Yeah, so there's 5 7-2 calculators. So they're a little more niched depending on what type of problem you're looking at. So we'll go through and so you can see which ones that you need. Alright, so the first couple of questions here, these t-values. So t it's very similar to the same thing as z. It's a particular cutoff and a bell-shaped distribution. It's just there's a little subtle difference between normal, which standard normal is z, and the t distributions, which there's multiple t distributions depending on the sample size. So when we're doing the 7.2 homework, t values with area to the right, remember we call those critical values in when we're dealing with z's, with the proportions. The same thing here, they're critical values. Notice this says area to the right on this one. So we have to make sure that it is giving me area to the right. So area to the right is 0.15. Alright, degrees of freedom. Degrees of freedom is 1 less than the sample size. So just make sure you understand that. Alright, so there's our critical T. And this is 1.076 to 3 places. I'm going to do the little split screen thing again. So 1.076. Alright, and then it wants to know, find the t-value. This is the area in the right tail is 0.005. Alright, so what's that going to do? It's going to make this number bigger because we are going out further in the tail. So 0.005, alright, but our degrees of freedom is now 18 instead of 14. So 0.2878. Or sorry, 2.878. Alright, and now notice this one. This one says, find the t-value such that the area to the left of the t-value is 0.05. So when those, this that I have highlighted in yellow, you can actually, when you click on it, this little arrow drops down, drop down and do to the left of the value. Alright, to the left of the value is 0.05 and 19 degrees of freedom. So notice, because it's to the left and it's a small number, it's in the left tail. The one thing that other than the bell shape, that one thing that t and z have in common is that mean, that middle value of 0. So if we're in the left tail, and we are, if there's just a small percentage to the left of us, that puts us in the left tail, then we're going to be a negative number. All right, if this number is bigger than 50%, then it'll be a positive number. But if it's less than 50, and especially if it's really small like this, then we're going to be out in the left tail, so we'll have a negative number. All right, to 3 decimal places, so negative 1.729. All right, and then 50% confidence with 25 degrees of freedom. So 50% confidence means that's the area between two numbers. Remember, a confidence interval has to have a number on the left and a number on the right. So when we do, when they give us the percentage of confidence, then that's the area between the two values. So there's a left number and a right number, and that's why it pops up and gives us 2 numbers now. And the confidence, 50% confidence, that means that the area between the two values is 50%. Right? If this had been 80% confidence, we would put a 0.8 there. It's not the leftovers. It's just the number that's between the two. All right, we got 25 degrees of freedom. Do make sure you update your degrees of freedom. Alright, find the critical t-value that corresponds to it. So we're just taking the positive number here because it says value, not values. Okay, so we're going to use the positive, 0.684. Alright, so even though it's given us two values, sometimes you will have to have two values for these and separate it by a comma. But if it only asks for one value, critical t value singular, then do grab the positive version one there. Alright, on these when you see lower bound and upper bound, that's the second one, sample mean plus minus e. So we just put in the numbers that it gives us for lower and upper. So 15 is my lower, 27 is my upper. So my x bar, my sample mean is 21, the margin of error is 6. So what that means is 21 is dead in the middle of these numbers. If I subtract 6, I get 15, and if I add 6, I get 27. So this number is like the average of these two, and this number is how far these are from the average. So the point estimate is 21, and then the margin of error is 6. So it's just calculating those four. These are very straightforward calculations. If you just click on them, double click on these, you see it's the average, and you double click on these, you can see it's half the distance between them. So this minus this, and that is the formula for those. I'm just plugging in the formula for those and using Excel to calculate it for me on the fly. Alright, let me blow this one up because I just want you to be able to see it. This is just understanding. A 90% confidence interval results from examining this many customers in a fast food chain's drive-thru, and it has a lower bound of 165.4 seconds and upper bound 169.2 seconds. Okay, what does this mean? Alright, so we talked about this. You got to have confidence in there. So one can be blank confident is going to be the part of it. It's not a probability that it falls between those two. And it's not a likelihood that we're getting the actual population mean a certain percentage of the time. Okay, so the confidence level, it's confidence level. I mean, it says confidence right beside it, so that's going to be part of it. One can be blank confident. It's not this number. It's between these two numbers. So that's what we mean by a confidence level, our confidence interval. So we're going to put our confidence level, and we're going to put our lower and upper, and just read it. That's what all of these things translate to when we construct a confidence interval. It's important that you understand this. We're 90% confident. The average of all drive-through times. Now we did 568 times. That's not all of them. You know, maybe there's tens of thousands in this fast food chain's drive-through. I mean, Chick-fil-A in Hendersonville does like that many in an hour or something. I mean, it's ridiculous. So this isn't all. This is a sample. And because it's a sample, we don't exactly know if the mean that we got is the actual population mean. We know it's the mean of this sample, and it's a relatively large sample. So we go up and down by a certain amount. And that's not a big gap. If you look, we're talking about 100 and roughly 65, 170 seconds. And we're talking about a gap of 4 seconds. You know, that's not a big percentage of the overall values that we're dealing with. And that's how far up and down we're going. It's a very good approximation of the population mean of all of them, of the thousands and thousands of these folks. Okay, so we are confident that we've captured the mean drive-through service time of all. I wish they would have put that in there in the answer. The mean drive-through service time of all customers, not just the 568, and that's what we've captured in here. That's what a confidence interval is. It's using a sample to estimate the population parameter. So in the last section it was percentages or proportions, and this one's its means. Alright, let me shrink this one back down so we can get our calculator back. So this one we are constructing an interval. So I'm going to go to the third one. So this is a confidence interval. Okay. So I'm going to plug in the mean is 12.6. I'm going to plug in S is the sample standard deviation, which is 16.6. And the confidence level is 99. All right. Our sample size is the 1006 up here. And there's our lower and upper, along with an interpretation of what the confidence interval is. All right, we are this confident that the population mean falls between these numbers. I wonder what happened to my critical values. I'll have to fix that. That should have critical values on there. All right, I added the critical values back, so I will update that on our Moodle, so they'll be there. But the critical values correspond to the confidence level and the sample size. So if this confidence level were to jump down to 95, for instance, we get different critical values, and let's do like 250 or something. So you can see that they do adjust with the sample size. Okay, so there is our lower and upper number that are going to go in one pair of these boxes. We just have to have the interpretation right. So we're 99% confident true value of the population mean. So the only one that says that is this one right here. All right, it's not a probability. It's confidence that it falls between there. All right, it's not a law of large numbers. It's a confidence. So we're going to say it's 11. What do I have to round it to? Two places. 11.25 is my lower, and my upper is 13.95. So again, I've talked about this before. This sheet will get these numbers for you if you pick the right ones. It will not pick the right interpretation of the confidence interval. You've got to know what a confidence interval is. Now, I try to get a vague description of it, but it's still going to be up to you to take the numbers and interpret it correctly. So do make sure you're working on that part of this. All right, here we got a data set. So this one right here, if you look, it says a confidence interval for a mean with data. So it says here, enter the data into column B. That's this stuff right here. You're going to put these numbers in there. I'm going to highlight them and just hit delete. Okay, all these errors and things show up. That's okay. And then I'm just going to start typing the numbers in. So 5.58, 5.72. Remember, when you see this little box, that lets you copy the stuff to the clipboard. You could open it in Excel, but you'd have to copy and paste it into this sheet to get to use this sheet. But if I go to copy to clipboard, and then you have to copy it again. I do anyway. Maybe you don't, but I have to copy it again. So I just right-click, copy. Then come up here to the very first column under B, or the very first cell under B, and then just Control-V to paste it. And so there it goes in, and there's our numbers. Okay, so it's created this. It's getting our point estimate. It's getting our sample standard deviation. We do have to do the confidence level if it's not 99, the default. So do make sure you're adjusting that. All right, point estimate for the mean is this number. To two places would be 5.02. And then our 95%. Do make sure you change this because it's different. 95% probability, nope. 95% confidence. That will be between 4.75 and, oops, I didn't type it in there. 4.75 and 5.29. All right, and then construct and interpret a 99% confidence interval. So I just go up a little bit more. And now I have a 99% confidence that we're between 4.63 and 5.40. All right, now what happens is the interval as the level of confidence has changed. So the level of confidence increases. We went from 95 to 99. Notice what happens to our numbers. All right, there's 95, there's 99. This one gets smaller and this one gets higher. That means the width of the interval increases. It gets wider. This makes sense since the margin of error increases as well. All right, the margin of error for these is this guy right here, right? So all this together. Well, this isn't changing because S didn't change, right? N didn't change the number of values we had. So these two values are stuck. If we're not adding more numbers or changing the numbers, and we're not, because there they are, they're just sitting there. So the only thing that's changing is this critical number. And just go back to the last one if you need to see that. When I go from 95, there's 12 in this sample size. When I go from 95, all right, negative 2.2, positive 2.2, to 99, negative 3.1, positive 3.1, we're going out further in the tail. This is, again, 0 is the center, so this is further away from 0 than this is. Okay, so the interval's getting wider when we increase our confidence. And it's literally because of that T alpha over 2. Those are the critical values for T distributions. Alright, so let's look at this guy. This is back to a summary. So we're back to just this calculator. We don't need the data. So we've got sample mean of 27.8. We've got S is 6.8. We got our confidence level. 98%. That's the one that we don't ever see. And then our sample size N is 199. Alright, just remember, sometimes they'll say sample size, sometimes they'll say degrees of freedom. They're not the same thing. So sample size is one more than the degrees of freedom. Degrees of freedom is one less than sample size. Alright, so there is our lower and our upper. Did I get my numbers right? Yeah. 26 point to just one place is 26.7, 28.9. Alright, are the results between the two confidence interval very different? 26.4, 29.4. Alright, are the results between the confidence intervals? So these are the two they want us to compare: 26.7, 26.4, 28.9, 29.4. These numbers are very different. There's crossover here, like this one's a little bit less than this, but this one is not less than this also. If these were drastically different, like the upper number would be smaller than the lower number here, or vice versa. The upper number here would be smaller than this one. And that would indicate that the confidence intervals don't overlap at all. And if they don't overlap, then we would conclude that the means for these two things are different, that these are different values. So, no, the confidence interval limits are similar. Alright, I want to get to, let me jump up to, these are all very similar. There's data again. I want to jump into the sample size requirements. So this is similar to the one you did for in the proportion one when you had to come up with the sample size. So how many subjects are needed? That lets you know. We're asking for sample size, so we're asking for N. Are needed to estimate HDL cholesterol within 3 points. That's our margin of error. So when you see the thing after the within 3 points is margin of error. 99% confidence. Sorry, I already got that. There's our estimated sample standard deviation. So we need 196. And again, it's a round up calculation. All right, so we already got the round up built into it. So we don't have to round that up again. So 196 subjects. All right, 95% confidence. If I go down, this goes down. So if I want to increase my level of confidence, again, unless any of these other things are changing, because this is how we get it, if there's a one-to-one thing, like this is what we're calculating, this controls the confidence level, and it's in the numerator. So if this changes, this gets bigger, this is going to get bigger. If this gets smaller, then this is going to get smaller. All right, how does a decrease in confidence affect the sample size required? Decrease in confidence level decreases the sample size needed. All right, and let's do one more of these sample size one. All right, we got 19.6 is our value for S here. 95% confidence within 4 books. So there's within, so after within is 4. So we need 93. All right, and then how many subjects are needed to estimate the mean number within 2 books? So now we're having our margin of error. And notice that went way up. All right, so what effect does doubling the required accuracy have on the sample size? So there is our margin of error. If we double that from 2 to 4, notice we went from 369 to 93. If I divide that, we almost have a 4. Doubling required accuracy is actually halving our margin of error. So having our margin of error, which is what doubling the required accuracy means, quadruples the sample size. So we went from 4 to 2. That's doubling the required accuracy, which halves the margin of error. That quadruples our sample size. So that's what D is. All right. So anyway, there's an example of how to use these spreadsheets for your Chapter 7.2 homework. So let me know if you have any questions about this, and I'll try to make a more specific video if you have any specific questions you want to address.